Okay, so the next speaker is Shan Huang from Queen Mary University of London. She's working with Steve Willig. She's a final year student, and her research interests are mailbox detection and internet measurement, so that's a good fit. And the talk will be about how HTTP is impacted by mailboxes.
Hello everyone, I'm Shan. I'm from Queen Mary University of London. Today I want to talk about the mailboxes in our current network, especially from the HTTP perspective. So firstly, let's talk about why we care about mailboxes. This is our previous academic network structure, the end-to-end network. And thanks to TCP, when the package go through the routers, there is no traffic flow manipulation happens in the middle. However, our current network is different. We have lots of mailboxes in our network, and they perform different kinds of network functions. For example, like proxy, cache, or filter, and so on. So when the traffic goes through these mailboxes could modify, could shape, or could classify these traffic flows, and sometimes drops the package. Sometimes drop the packets for purpose. So we could say mailboxes break the end-to-end network architectures. And also, at the same time, we could learn some information about the involved networks from the mailboxes. For example, when we see a firewall, we will think about, oh, maybe there are something related to security functions, and maybe there are some places of censorship. For example, like the Great Firewall of China is a complex mailbox system. And the people who want to learn more things about censorship need to detect the behaviors of related mailboxes. And also, mailboxes could tell us some information about the involved networks. If you see a mobile network gateway, you could infer that there may has a mobile network. So overall, in all these studies, we by launching the HTTP request, we show the evidence of some presence of HTTP interfering mailboxes, and at the same time, we do some analysis about the involved networks. So how to detect mailboxes? So this is our original client and server architectures. We want to control both client and server at the same time to generate and capture the traces from both end hosts. And if there is no mailboxes, the traffic will go through the internet directly and reach the server side. The traces will not have some modifications. However, if there is a mailboxes, the mailbox will manipulate the traffic flows in paths. And as we know, mailboxes are complex. They are operating from network layer to application layer. So, maybe in the past, in the middle, there are multiple mailboxes. So we treat all of them as one black box, and we check and capture the incoming and outgoing traffic flows, and we compare the difference of the received traces and the original prompt traffic flows, and to identify what happens in the middle. Okay, so the next step is that we want to launch requests from as many as possible vantage points across the world. Firstly, we run our script in Planet Lab. Planet Lab is not suitable for studying mailboxes because most of the instances are in academic networks, and we do not have some good results about in Planet Lab. So we need to change to another commercial platform. Hola. Hola is a peer-to-peer VPN networks. They forward the user's request through lots of country peers, which distributed all over the world. And from some news or advertisement, we could see that lots of users use VPN to access any website and we believe in that they have enough country peers for us to use. And when we began to launch our request from Hola, we found that they forward our request through their super proxy, which only distributed in US, UK, and Netherlands. That is not what we need. We want to make sure our request is launched from the country peers. So we changed to Illuminati. Illuminati is a paid services which is based on Hola network. And for Illuminati, we could set the country code inside our request, and the super proxy will select its country peers for us. And with Illuminati, we could make sure our request is launched from the country peers. Okay, next I will explain how Illuminati works in details. We control the measurement client, the crawler, and servers at the same time. Both of them are operating in Amazon Cloud instance. And for the super proxy and country peer belongs to Illuminati. We do not have the access. To these two elements in Hola networks. And when I want to launch a request from the country peers, I firstly send the request to one of the super proxy. And then the super proxy forwards my request to the available selected country peer, and then the country peer will forward to the destination server. And when the country peer receives the response successfully, it will return to the super proxy, and super proxy inserts two new headers to describe the selected country peer and response to the measurement client. So in the measurement client, we could get traces of the received request and received responses, and we want to compare the differences of these HTTP messages, and based on the HTTP message manipulation, we want to learn more things about Middleboxes. And if you, for our target is measurement the Middleboxes between country peer and server. So we treat the country peer as our client and the server, and we want to also have our client and server architecture based on Illuminati platform. And this is an example that if there are some proxy, modify, or insert new headers, we could, by analysis the captured request, we could see the manipulation inside the HTTP headers. So in total, we have received the request from nearly 400,000 different IP addresses, and we received the response from nearly 370,000 available country peers. And this diagram shows the distribution of all the of the selected country peers, and we could see that it nearly covers most of the countries, except 2 countries in Africa and 1 in North Korea. And corresponding, according to the IPs, we map the IPs to the corresponding ASs and countries. And this diagram shows the number of AS per country. And we want to know more details about our ASs, so we do a classification of these ASs. We didn't use the traditional kind of database because it didn't provide us very clearly categories. So we try to use a machine learning approach to do the classification of the autonomous systems, which is published in 2006. And we have detailed categories in this method. However, the coverage of that database is not good enough. So we have nearly 67% of ASs are unclassified. So we also argue that if we want to know more things or more details about the networks, we need the method to classify the involved ASs. And from the classification we could notice that most of the vantage points are at the edge of networks. That is what we really need. So next section, I want to describe our results. Our results are two parts. The first part is about the request header injection, and the second part is the response header manipulations. We noticed we observed lots of new header injections in our results, and some of them could represent the functions of related Middleboxes, for example, like proxy or like cache. And we also have some of headers are non-standard. We need to guess or infer the functions of involved network based on these headers. So this is the first part is about the injected request headers related to network functions like proxy, cache. And because some of the ASs are unclassified, so the accurate number of involved ASs and countries are listed in the table of our paper. And we found that nearly 65% of ASs injected Y, and Y is the most popular injected headers related to proxy functions. And it could carry some information about the proxy. We not only check the header names, but also about the values of these headers. And the values are consistent with the header names, and all of them prove the presence of some proxy or cache related Middleboxes. And ACT forwarded 4 is observed in more than 500 ASs across nearly 106 countries. And ACT forwarded 4 also carries some private information about, like it carries the private IP addresses of the users. And we also noticed that there are some specific vendor Middleboxes. For example, at the XBlue code Y, this header is only used for XBlue proxy. And also, for example, the headers with the prefix IWS. IWS represents Internet Web Security. It's a kind of software, a kind of network services for security purpose. And these two headers are aided by trained micro Middleboxes. And we noticed that here, they treat the Internet Web Security as a kind of services which may be used for cloud instance. And then we check the ASs of this request, is from the Amazon cloud instance inside the Japanese data center. So we show the evidence that Middleboxes are also used in the cloud platform. And then we see some non-standard request headers. We try to infer or try to guess the use of these headers. Like this two is the special headers which are used in O2 mobile network, carrying the ID and location of gateways. And these four, we noticed that the Nokia prefix, so we guess that these four headers are related to some mobile devices. And we all think that these middle boxes come from the mobile network. And these two headers are used for describing the radio technology in the particular network, mobile networks. So from the injected request headers, we see lots of headers related to different kinds of network functions, and also the headers are injected from nearly 100 different kinds of countries. And the second part is about the response header manipulation. We wanted to show that the middle boxes not only affect the upstream traffic flows, but also have some effect on the downstream flows. So it's worth to controlling both the end host and to have the traffic in both directions. And for the response header injection, most of the injected headers are related to cache. For example, Xcache is the most popular one, and it is observed in 519 ASs across 105 countries. And we also noticed the two specific vendor caches in our results. And compared to the request header, we see less information about the Unicode or gateway in injected headers by middle boxes. Like for the request headers, we know some X proxy ID or the end client information in the injected headers. But for the response part, the injected header related to proxy is only for the proxy connection. And we see two ASs in two countries inject the set cookie header. We know that set cookie is aided by some third-party servers. We are not sure whether these headers are injected by third-party or middle boxes, but this result shows that there is risk about the user privacy inside the internet. And also, we see some non-standard response headers, like client date, client peer, client response number. These three headers are not very popular, and they are injected by the Smart One, a mobile operator inside Hong Kong. So we could infer that this request is from the mobile networks. And similar with the Nokia case, these two headers with the Android prefix are related to the middle boxes inside wireless or mobile network. And also for the response headers, we also see some cases about the middle boxes modify the value of the last modified header or E-tag headers. So all of them will affect the performance of the cache. And so overall, our Middleboxes provide lots of functions for today's internet, and we could see there are a lot of headers to provide the functions of these Middleboxes. However, sometimes the Middlebox negatively affects the end-to-end performance. And for our work, we study the presence of multiple types of HTTP interfering Middleboxes and detecting the Middlebox interference in more than nearly 1,000 ASs. But limited by the sampling of available vantage points, we argue that for future work, it's needed to better estimate the sheer number of the Middleboxes deployed in the internet and their actual impact. We need more samples from mobile network, from cloud platform, and we could detect more Middlebox functions and use this result as a identifier to classify the network, the involved networks. So thank you.
Thank you very much. Are there questions?
Yeah. Yeah.
Yeah.
Very interesting. As far as I know, Illuminati is basically a peer-to-peer VPN service that is also using Gigabit points that are located in unsensitive distances or something. So have you looked at the distribution of headers within a given IS? Because I guess that some of them might be actually, as you said, related with intrusion detection systems. So they do not necessarily have to be associated with the ISP. They could be with a Middlebox that is located in a given network. So have you isolated and analyzed the distribution of those within a given IS?
For our result, I like the request. I think. We check all the IP addresses and so. Sorry, could you repeat your questions? Sorry, could you repeat your questions?
Yeah. My question is that you're attributing headers to an AES, right?
Yeah.
But an AES can have different configurations because some of them might be enterprise networks that can deploy Middleboxes from some security vendors. So in Illuminati, you don't really have control on whether the user is located behind an AES or not. So my question is if you try to analyze the prevalence of those headers for AESs in which you have multiple egress points, because then you can see if this effect is or if this observation is.
So if for example, if the manipulation happens inside the Illuminati networks, so all our requests or all the related requests from that AS should have the same manipulations. But for our result, we do not see this kind of manipulations. We only see the some different kinds of IP addresses. So it's not from one AS.
We can chat with it.
Yeah.
So what I would be interested in is, have you looked at if there's some correlation between Middleboxes on the request path and the response path?
Yeah, we see in both directions we see some headers with the same functions, but they are not stateful result. So when the request, so the injected header or manipulated headers are not related with the upstream or downstream. They have some headers with the same function like cache, but it's not a map with upstream or downstream.
Okay, other questions?
Yeah.
That's really interesting work. So did you see any evidence of censorship?
Yeah, we see some headers, injected headers related to URL filtering. So like the headers list the headers the name contains URL to filtering, and in the value of that headers have our target destination links, and we also see some related blocking page returned in the response part.
Okay, so what I would be interested in is, have you also thought about doing this for HTTPS or HTTP2?
Yes, HTTPS is maybe is for our future work, because Illuminati also provides the HTTPS request. So maybe we could launch the HTTPS request to see what happens about Middleboxes.
Yeah, but I mean then either you have a Middlebox that breaks the connection, or otherwise you can't. I mean, then you need another method to figure out, right? I mean, if you have really strong end-to-end encryption and the Middlebox can't break up the connection, then you can't. The headers won't change. Right?
Yes. Yeah.
Okay. So, is there no more questions? Let's thank the speaker again.